your chain hang low, I ask you, well, I don't know. I really don't know what that means. I heard on the radio years ago, and I've always wanted to say it in the appropriate setting. And here we are, because we're talking about the chain rule. A function within a function is also known as a composite function. In this case, I have a function living inside a function. I have sine, usually I have sine x, but in this case I have sine of x squared minus 1. So I have a function, a g of x, living inside another function, f of x. So this could be rewritten where sine is my f of x and g is my inside stuff. I'm going to have outside stuff and I'm going to have inside stuff. What am I supposed to do if I'm being asked to take the derivative of something with inside something else? I mean, this is sine. I'm not allowed to distribute sine to the things inside. That doesn't make sense. Okay, so when I do a function within a function, I use what's called the chain rule. And so this is what the chain rule looks like. But simply put, the chain rule, what you do is you take the derivative of the outside, keep the inside, and multiply the whole thing by the derivative of the inside. Take the derivative of the outside, put it where it's supposed to be, keep the inside, keep it where it's supposed to be, but then multiply the whole thing by the derivative of the inside. All right? Document camera. All right, so there's my chain rule, which again says you take the derivative of the outside, keep the inside, but multiply the whole thing by the derivative of the inside. So let's take a look at that exact problem that we just saw. Okay? This is the outside. Okay? This is my f. My g is the inside. So the derivative is going to be take the derivative of the outside. The derivative of sine is cosine. Keep the inside, x squared minus 1, and multiply the whole thing by the derivative of the inside. The derivative of the inside is 2x minus 0, so 2x. So my answer after all of this is just rewriting 2x cosine x squared minus 1. Okay? See, not so bad. I have a function living inside another function. Okay, my one function, the inside, my g, is that polynomial right there. My outside is the exponent. So I take the derivative of the outside. So whatever to the 6th power means I drop that 6 down, make that a 5, keep the inside stuff, which is going to be x squared minus 2x plus 1, and multiply the whole thing by the derivative of the inside stuff. The derivative of the inside stuff is going to be 7x to the 6th minus 2 plus 0. So I guess kind of cleaning all this up. F prime is 6 x to the 7th minus 2x plus 1 to the 5th, 7x to the 6th minus 2. Let me silence my phone. All right, now C is going to look kind of bizarre. Okay, but go with me here. I'm going to rewrite C as this. Cos squared of x means cos x, cos x. So what I have is I have cos of 4x cubed minus x times cos of 4x cubed minus x. I'm going to treat this like product rule. So u is going to be cos 4x cubed minus x. U prime, rather, has me use the chain rule. So the derivative of the outside is going to be negative sine, keep the inside, and multiply the whole thing by the derivative of the inside, which is going to be 12x minus 1. 12x squared minus 1. Similarly, v prime, or regular v, is going to be cos 4x to the third minus x. V prime is the same as we got before. Take the derivative of the outside, keep the inside, multiply the whole thing by the derivative of the inside. And now I'm going to use product rule. The derivative is going to be u prime v, so negative sine 4x to the third minus x times 12x squared minus 1, u prime v. V was cos 4x cubed minus x plus v prime u, which is literally going to give me the same exact thing. The same exact thing. So I'm going to actually make that minus sine 4x cubed minus x 12x squared minus 1 times cosine 4x to the third minus x. So I have minus blah, 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 minus the same blah, 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 which gives me negative 2 of those blah, blah, blahs. Sine 4x cubed minus x, 12x squared minus 1, cosine 4x cubed minus x. Never said it would be easy. I just said it would be fun. And it was fun. I could have done chain rule within chain rule too. Nah. All right. G prime. Oh, that just becomes 4. Minus, take the derivative of the outside. So I have tangent and stuff on the inside. So the derivative of tangent is secant squared. Keep the inside. X squared minus 2x plus 1, and multiply this whole thing by the derivative of the inside, which is 7x squared minus 2. 7x to the 6th minus 2. And that should do it for that one. I'm going to rewrite E and make it look like this. Make sure you can see what I'm doing. So this is chain rule. The outside is 1/2. So the derivative of the outside is going to be bring that 1/2 down. Keep the inside. And multiply the whole thing by, oh, and you know what? I forgot to put to the negative 1/2. And then multiply the whole thing by the derivative of the inside. Oh, look, chain rule again. So I have sine squared x, which is, and again, if you're wondering, how is that chain rule? Sine squared x is the same exact thing as sine x squared. So if I were to take the derivative of sine x squared, you would bring the 2 down, you would keep the sine inside, and then multiply the whole thing by the derivative of the inside. So I have 2 sine x cos x. So 2 sine x cos x minus 4. there's a few things here that I can do. So I'm going to do it. I'm going to have the square root. Oh, that's on the bottom. So I have y prime, that's on the top, and I can factor out a 2. So 2 sine x cos x minus 2 over 2 times the square root of sine squared x minus 4x, and the 2's would cross out. Just checking to make sure I didn't do anything. So, I mean, if you were to answer like this, I'd be happy, but really the answer should look like this. F. Looks like what I'm going to do is I'm going to have quotient rule and then chain rule and then chain rule again. Gross. So my u is going to be 7x to the 4th minus 5 squared. U prime is going to be chain rule. So take the derivative of the outside, which means bring the 2 in front, leave the inside, and then multiply the whole thing by the derivative of the inside. V is going to be the square root of 5x minus 4, which, by the way, could also be written as 5x minus 4 to the 1/2. So V prime is going to have me bring that 1/2 out front. Okay. 5x minus 4 stays on the inside, negative 1/2 because you subtract 1, multiply the whole thing by 5. And that ends up looking like 5 over 2 times the square root of 5x minus 4. And v squared is actually the easiest part, because the square root squared becomes just the regular old number, or the regular old thing. So, f prime of x is going to be u prime v 2 times 7x to the 4th minus 5, 28x cubed minus v prime, which is 5 over 2 root, wait. Did I forget u prime? I forgot v. Ugh. I knew I was missing something. All right, u prime v. So u prime is going to be 2 7x to the 4th minus 5 times 28x to the 3rd v, which is root 5x minus 4, minus v prime, which is 5 over 2 root 5x minus 4, u, which I could put up here, is 7x to the 4th minus 5 squared, all over v squared, which is 5x minus 4. And that, ladies and germs, is all I'm going to do for that one, because there's really not much of a way you can clean that up and make that much prettier than that. That's pretty bad. It's not going to get much better. But it's the last problem, so you have that to be thankful for. All right, that'll do it for this section and this chapter. Bye!